Have you ever wondered about life? Perhaps you have wondered. How does everything around you connect? On this rare planet, there are millions of relationships between multiple individuals. The environments that these beings inhabit, or the food they consume, are of a diverse nature. We are without a doubt one of the most extraordinary phenomena in the universe. In your intestine, a very hostile place, colonies of bacteria survive thanks to the food you eat. And ironically, you depend on the same bacteria to digest your food. Whether inside your body, or in lakes full of arsenic and salt, or in a small drop of water, life has adapted and has made this planet an inhabitable world. This process, which began on our planet billions of years ago, has, with atoms, written a valuable legacy. An inheritance that is present in everything alive. An inheritance also present in you. By occupying the outskirts of our planet, we achieved a privileged perspective of the world we inhabit and the place we occupy in it. In this imbalanced system, we and millions of other species harness and transform the energy that emanates from the sun. But what are the possibilities of a complex process like this, also existing beyond heaven and beyond Earth? Maybe on another planet? Let's take a trip, but this time, let's travel through the questions. Those questions that the very existence of life make us ask. Welcome to Life's Question. We exist in a fertile time for life in the universe. Today, the ingredients necessary for life and for planets to be formed, like Earth, are found everywhere. But it wasn't always this way. At some point, the universe did not have enough ingredients to form something as complex as life. It didn't have oxygen atoms, like the ones you are breathing right now, or carbon atoms, like the ones that your body is made up of. Actually, for you to be here today, searching for new questions, certain stars had to be born, and others, unfortunately, had to die. Let's discover the origin of the ingredients that life is made up of. For this endeavor, we will travel back in time. Shortly after the birth of the universe, the first groups of atoms were formed: hydrogen and helium. Today, these atoms account for the majority of atoms in existence. They are also the raw material necessary to manufacture new elements. The main fuel which caused these gigantic stars to burn is hydrogen. Within the nucleus of these big furnaces, new atoms, such as oxygen or phosphorus, incubated. The smaller and later generation stars also used hydrogen and helium as fuel, which they also utilized to manufacture new types of atoms such as carbon and nitrogen. What we call cosmic rays are really debris of atoms released at great speed by the violent death of certain stars. These small pieces of atoms collided with others in their path, creating new atoms such as lithium, beryllium, or boron. Recently, humans have also contributed to the alchemistic labor of the universe. We have synthesized new classes of atoms in laboratories, such as copernicium or einsteinium. The bursts in which the biggest stars die are called supernovae. In a single explosion, the new material of the stars that has been fused from its nucleus is shot out at high speeds. Some heavy elements are formed from supernovae, such as the gold in jewelry or the iron in your blood. All of this cosmic activity, the violent bursts of material and energy, the life and death of small and giant stars, the cosmic rays, and the birth of the universe itself are the mechanisms that originate the ingredients from which life is made and have given form to the matter that exists today. Not all atoms have a leading role in this story. There are 6 elements that are the fingerprint of life on Earth: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, also known as chnops. These are the letters of the acronym with which the earthly work of life has been written. These elements, in turn, dance to the chemical evolution of the Earth and the solar system. They form the various chemical combinations which allow life to operate. We call them organic molecules. Organic molecules can form innumerable combinations when dissolved in water. From them emerged very complex chemical properties on Earth, including encoding and preserving vast amounts of information, the function present in DNA. Furthermore, time played a crucial role in the emergence of the affinity of these atoms, molecules, and later in life itself. At this very moment, millions of cells read and translate a message inside your body. This message has been encoded in our DNA and preserved by life. However, this genetic information has also been edited by viruses. These microscopic structures are a gray zone in our understanding of what is alive and what is not. Despite carrying pieces of DNA and their intriguing complexity, viruses are not classified as living beings. But this doesn't stop the hacking process that they do to living cells. What about other planets? Can life only exist on Earth? What is hidden in the unexplored landscapes of our neighboring worlds? Is the existence of life on Mars possible? This is the Mars Science Lab, also called Curiosity. an explorer responsible for finding answers and refining our questions about life's possibilities, while thriving in harsh environments like those on Mars. Its mission, which is just beginning, is to gather enough information about the red planet's surface and send it back to Earth. The gases in Mars' atmosphere, the chemical composition of its soil, and the amount of water on its surface are data elements that will help us understand the mysterious past of this planet. Half a ton of chassis, scientific instruments, atomic batteries, and lasers for examining rocks could provide us with a better understanding of this nearby world, which once had oceans and rivers flowing across its surface. Did something similar to life ever exist on Mars? Could it exist today? Curiosity has studied some rock samples, and despite not finding life, it has detected in some of them high levels of methane gas, levels almost 21 times higher than previous readings. Methane is an organic molecule made of carbon and hydrogen. Here on Earth, it is food for certain types of organisms, but it is also the residue that other organisms release. Current characteristics of Mars, including seasons, a similar day duration to Earth's, organic molecules, and frozen water, provide an advantageous environment for future life habitability, and it depends highly on our perseverance to continuously discover this world. Life and space rocks are closely related. Even before Earth was formed, some rocks carried within them an essential ingredient for life: massive amounts of water. In fact, much of the water that is currently on the surface of our planet came to us thanks to comets. These mountains of ice and rock, which drift through the solar system once every few decades or even hundreds of years, contain frozen water, precious metals, and again, organic molecules. Despite not being a life-friendly environment, comets are vehicles that carry much of the water available in our solar system. Alongside the gaseous planets, an unexpected possibility for life is available. Their moons. These little worlds that orbit the giant planets can hide seductive scenarios for life. Enceladus is a moon of Saturn from which water vapor spouts. This tiny world, just 500 kilometers in diameter, offers us great questions. Liquid water spouting from a moon? That far from the sun? These geysers expel salt water from an inner ocean, which gestates in the belly of this moon, thanks to the heat emanating from its nucleus. This proves that the environments necessary for life, like oceans, are possible beyond Earth. Beyond Enceladus, in the interior ocean of Europa, one of Jupiter's moons, is an amount of water greater than all that exists on Earth's surface. In this type of lunar oceans, there could be conditions similar to those present on Earth before life was formed: oceanic environments, heat sources, and organic molecules. Moons like Enceladus or Europa are worlds that challenge our certainties about the environments possible in the solar system. There is enough energy inside them to melt ice into water, making ocean environments possible. Titan is the largest moon around Saturn. It is even larger than the planet Mercury. This toxic world has conditions hazardous for life as we know it, such as liquid methane rains and lakes. However, it has an important attribute: a dense atmosphere. These conditions reveal a highly diverse solar system where water is abundant and ocean environments or atmospheres are not exclusive conditions of the planets. There are still 200 worlds to discover in the solar system. What about the other planetary systems? The Sun is a small star, just a point of light, which together with hundreds of billions of other stars make up our galaxy. There are millions of planets and moons out there. Some of them should contain environments favorable for life. The super-Earths are rocky worlds almost twice the size of our planet. These rocky planets could contain much more water than Earth and most likely have abundant CHNOPS atoms. Also, the moons outside our solar system, or exomoons, could provide a wonderful chance for life. We know about the immeasurable amount of stars in the universe. Now imagine for a moment the number of planets around them. Moreover, imagine the number of moons that exist in the entire universe. Our limited observation has allowed us to contemplate diverse possibilities for the development of a complex process such as life. But this process could also exist in the future of new worlds that are now being born. This galaxy, called the Milky Way, is just a small island inside a universe that has hundreds of billions of them. The matter from which the moons, planets, stars, and nebulae are made is only 5% of everything in existence. The rest of the cosmos, 95%, seems to be made of dark matter and energy, two entities that we are just now discovering. We are part of one of the most exotic forms of matter that exists: atoms. The evolution of the universe and the passing of time allowed life to emerge on a planet like Earth. In all this vastness, we embody that small but inevitable possibility. But we are also the evidence of an intelligent life that is able to ask questions about itself, and consequently help our cosmos become aware of itself and its plural reality. A multiverse. Astrobiology is the study of the phenomenon of life as a spontaneous property of the universe. Two prominent scientists in this area, Carl Sagan and Frank Drake, designed a radio signal message to test the power of a radio telescope. This 210-byte message travels at the speed of light to a star cluster and carries with it information about Earth, life on it, and the solar system. It is a message in a bottle in the oceanic reality of the universe that may or may not have a recipient. We have explored the origin of the ingredients that are indispensable for life on Earth. Conditions inside and beyond the solar system are ruled by the same physical laws. It's impossible to not guess another possibility for a phenomenon such as life. The lunar oceans and superhabitable planets can house conditions suitable for chemical evolution. This fertile quality of the universe has evolved thanks to mechanisms such as the life and death of stars. This part of the universe that we call life, capable of adapting and being resilient to extinction on Earth, is the same that drives us to search for answers about our origins. Oceanic environments where Earth's organic matter could evolve appear to not be so scarce in the universe. We are the aware part of the universe. You are the part of the universe that can study itself, and then wonder about the close connection between everything in cosmic evolution. You are the part of the universe that is able to formulate life's question.